addition, subtraction, multiplication, division. Composition is actually when you like put one function in for another function. And so we call that the composite function. And we denote it with this little open circle. That's not a time sign. That's not a zero. That's not a circle. I mean, it kind of looks like a little open circle. But it means f of g is how we read that. Not f o g, not fog, not f times g. It's read as f of g of x is how that's read. And really, when I teach this in Algebra 2, I always say that little circle can just be replaced with another set of parentheses. It just means like taking one function and putting it into another function. And so this would be the same as saying f parenthesis g of x. So notice, I can just replace that with another set of parentheses, and that is the definition of the composition of two functions. It's not multiplying two functions, it's composing them. The difference between this and what you do in Algebra 2 and Pre-Calculus is that in this class, they really want you to think about the domain of f of g, which is a little bit tricky sometimes. They talk about it in the book, they draw some pictures. I'm just going to write it out, and then I'm going to give you some steps to do it. But the domain of this is the set of all numbers x in the domain of g, such that g of x is in the domain of f, which just kind of sounds like a crazy mess sometimes when you're reading it. But basically, you have to look at the domain of g, and you have to look at what values in the domain of f will equal g and exclude those values too. So we'll do some of those today. There are questions on the unit test that ask you about the domain, so we want to make sure that we understand how to do that. Okay? Are you done with that? Not quite. Your brother had his wisdom tooth out already? Taylor? What's the F? Are you good now? So part of the homework today is we're just going to practice evaluating numbers with this. Oh, look, I didn't take attendance. That's what this is about. Hello? She's absent. Sucker. We're supposed to take attendance first and second hour, so then they look at all who's absent first and second hour and compare them, and then if there's some discrepancy, then they call and check. So like if you come in late, or someone marks you absent first hour, but you're here second hour, but Taylor is my second hour TA, and I didn't take attendance in the second hour, so that's why they're checking on her, because I didn't take attendance yet. It's all my fault. So if they give you f of x and g of x and they ask you to do this, really it's just working it out. I say start with the inside function and work your way out to the outside function. And once we do a couple of these, hopefully it'll jog your memory if you forget how to do this. But I always rewrite it with parentheses. Like this is the same as saying f of g of 1. And if you write it like that, just start with the inside and work your way out. So can you figure out what g of 1 is? And I'm going to show a lot of work on this, and I know you won't, but that's okay. G of 1, what does that mean to do? For g of x, plug in 1. So I could say that's the same as 4 times 1, or that's the same as saying f of 4. And then what do you think you do? Yeah, now do f of 4, which means for the f function, plug 4 in there, and that would be 2 times 4 squared minus 3, which would be what? 16 times 2 is 32, minus 3 is 29. That's it. And so they can just ask you to do some other ones here. And they just like to show you that composition is not commutative. Meaning that if you add 2 plus 3, it's the same as 3 plus 2. If you multiply 2 times 3, it's the same as 3 times 2. But if you take f of g and then you take g of f, those are not necessarily going to be the same answer. They could be the same answer every now and again, but for the most part, you don't get the same answer because you change the order, right? So now on this one, f is the inside function. So now if you do f of 1, 2 times 1 minus 3 would be negative 1. And now g of negative 1 would be 4 times negative 1, which means the answer is negative 4. So it matters which function is written first, g or f. Yeah, you can also compose a function with itself. So f of f or g of g, it just means you plug it into f twice. And again, you just still kind of work through it, just some good old arithmetic here. And I know people are going to like do this in their head, and I'm okay with that. What do I do that for? This should say f of negative 2. So f of negative 2 would be 2 times negative 2 squared. So that'd be 4 times 2, which is 8, and 8 minus 3 is 5. Right? That's kind of what I expect that you're going to write on your paper. You're more than welcome to show more work than that. And then you're going to do f of 5, which would be 2 times 5 squared minus 3. Order of operations, 5 squared is 25. 25 times 2 is 50. 50 minus 3, I think, should be 47. So how about do g of negative 1, and when you get your answer, write it on your little whiteboard that's under your desk and show it to me. Except for Megan doesn't have to.
Really?
No, I'll get her with that. Where I put one on every desk last week. Tonight is done. Which makes me feel like someone stole one. I still like it. I haven't done this. I'm just taking the answers that I see. Looks good. Everybody got
Can we get a thumbs up if we get it right?
No.
Please? What? We get it done if we get it wrong.
No.
It's Friday.
We'll have fun.
Yeah, thumbs up.
We'll see. I have them later.
No, I can't have thumbs up.
Because this is right on the wall, so it's pretty cool. Okay. I can play on the outside wall. Negative 16 seems to be the common answer. So there you go. That's all you need to do. More does now.
It's really curious.
Isn't this much faster than clickers? That's why we're doing these now. We're giving up on the technology. And it has a graph on the back. I know, right?
Well, I think the clickers are better.
G of negative 1 would be negative 4. Oh, that's easy. Negative 4 times 4. I know, that was silly. Okay. We'll do some other time, but this is just faster to do this quick little thing than to do clickers. Why did nobody what? Oh, I don't know, because we're trying to do technology here. I feel like the idea of technology is really cool, and like you could use clickers, and I could use clickers for a quiz, and then I can go and look at how many you got right. The idea is great, but it just takes way too much time, and I don't think that the people that think about them, like, oh, it's so great to use these, you can get instant feedback. It's not really that instant when you have to log in, and then it won't find it, and then it turns off, and then my board freezes up. Like, Mr. Pecca was observing me, and I used clickers, and, like, the board froze up, and, like, it did it, like, it just kicked everyone out of the question, and some people hadn't answered, and some people hadn't answered, and it's just, like, technology is a crap sometimes.
You like have to play demos, like a lot of times you have info on there, like everybody's like, oh, use a computer, use a projector.
And then it doesn't work.
Use technology. Yeah, like Mariah one time was doing a projector didn't work, and just had to use the computer screen. Get lost because of it. these posters.
Miss buys smartboard. They just put a smartboard in her room, like in that room over there, and it's the same as mine. But for some reason, her heat there comes right over, and it overheats her projector every day, and so she has to open her window and try and like freeze her students to try to keep it cold enough so her projector, because if it gets too hot, the projector just shuts down, and so then she just has to use the chalkboard. And they're like, there's nothing we can do. Your heater does that, so when the heat's on, you just have to deal with it. Like that's what her answer was. Like you think they would have thought about that and like put the smartboard on a different. Yeah. That's what I would be demanding. I miss buys two nice two different things.
Well, I do.
What? You don't know. Mr. Bucket and I have our moments of like when I go in his office, I feel like he just has those like, oh my gosh, what's she here about now?
Probably.
I just like tell him what I want him to do. Like he's always like, what do you want me to do? You just tell me.
I have a question. Do you remember Travis Gray? We haven't. I work with him, so we don't get asked.
He didn't make me cry. I saw him at the Putnam County Fair this year, I think. I think so. I know, right? Travis Gray. I think that's who I saw. No, Travis Gray?
Travis Gray.
Travis Gray. I was thinking Travis Hall, but I know Travis Gray too. He's like the little guy, right? Yeah.
Yeah. He, oh my gosh, he made me so funny. He's like, I'm 5'6". I was like, no, you're not. I was like, you are short.
Him and John Davidson were both in my Algebra 2 class. When I had Parker, like I was pregnant with Parker, and they sat in the front row, and they were both very concerned that like I was just gonna have a baby right in front of them. Yeah, and I had to assure people that having babies doesn't happen that fast, and that it wasn't gonna happen. So yeah. Not for me at least. It takes a while. Okay, so there's kind of a little bit of writing on this because there's steps, but I feel like these steps are going to be helpful to you. So let's write the steps down, and then I don't know if I'm going to have enough room to do the steps at the same time. I might have to, maybe I'll just double page this at the same time. Add a page. Double page. Here we go. Can you still see that? Split. So, step 1, find the domain of g of x. And I picked ones that had a restricted domain because obviously if the domain for f of x and g of x are all real numbers, does it make sense that the domain of f of g of x is also going to be all real numbers? So that, if it's all real numbers, you just get to say all real numbers. But if there's something with an x in the bottom, or there's a square root, if there's some restriction in the domain, then you have to find it. So step 1, we're going to find the domain of g of x. So if g of x equals 4 over x minus 1, what can't x equal? 1, right? Because I can't have 0 in my denominator. So that means for f of g of x, that's also going to be a restriction, but I'm just going to remember this now. I'm going to say x cannot equal 1. I'm not even going to write it in fancy domain lingo right now. Yes? Step 2 gets a little crazy, okay? I should have made this like 3 steps, but instead I just wrote it all. So step 2, find the domain of f of x. And instead of just saying that can't be in your domain, what that means is that g of x cannot equal this value. So you're going to solve g of x equal to this number and exclude it from your domain. So write that out, and then we'll actually do it right next to that step, and then hopefully that'll make more sense than what that does. Can you tell I just made these steps up myself? Whatever the domain of f of x cannot equal. I'll show you. I don't know. Maybe we should just do it and then you can understand.
4 over x minus 4. I'm trying to simplify it so I don't have to write like a big, gigantic.
Come on, it's like 3 sentences. I think we should do matrices after this chapter. I like matrices.
Oh.
I think we should just do a project. I think we should make it.
I like trying to add music.
I was like, what is this about Step 2. What can x equal in f of x? F of x equals 1 over x plus 2. What does that mean? What can't x equal? Negative 2. X cannot equal negative 2. You with me on that part? But instead, like what seems to make sense, like what people want to do for the domain of this is they want to just say, what's the domain of g of x? What's the domain of f of x? That's my domain of it together. But that's not true because you're taking g of x and you're plugging it into f of x. So I tried to write this out. This means that g of x cannot equal this value. So I'm going to say this means g of x cannot equal negative 2. So we need to solve g of x and find what x values in g of x make it equal negative 2. So that's what I tried to write up here. So this means that g of x cannot equal this either. So now solve g of x, which is 4 over x minus 1. Solve that equal to negative 2 and tell me what is the solution to that. Like what is the x value?
So when it's not equal to
Yeah, like this is going to be not equal to when we're done with this. What would I do to solve this? We could get a common denominator, but also, I think, less work. Could I just multiply x minus 1 over? Yeah, common denominator will also work, I promise. You'll still get the same answer. But yes, it's just a proportion, or you could just multiply x minus 1 over. Because if you multiply by x minus 1, it's going to cancel it out over here. And I'm going to get negative 2x plus 2. And I'm just going to solve that for x. So when I subtract 2, I get 2 equals negative 2x, or, sorry, not equal. X cannot equal negative 1. So that's kind of the tricky part of the domain. In pre-calculus, they talk about the domain of f of g, and I've always just skipped it because I feel like people get confused on it. But I have to teach what's on the unit test, and finding the domain is on the unit test, so maybe I should stop skipping it in pre-calculus. It's the lesson I've learned. Because it's not really that bad, it's just steps. So step 2 is the hard step. Step 3 is just put the values that you got in step 1 and the values that you got in step 2 together, and that is your domain. So for this problem, the domain is x can be anything but 1 and negative 1. So my domain, and it depends on how you want to write this, it's probably just as easy to do it in set notation and say x could be anything, but x cannot equal plus or minus 1. Interval notation, you just got to skip negative 1 and 1. So that would be negative infinity to negative 1, negative 1 to 1, and 1 to infinity. Those little u's in there. Like definitely when there's more than one thing, I think set notation is just like way better. You with me on that? So really, this is all we're doing today. So what we did for the first part, which I don't think is so bad, and then the domain stuff. So let's do another one of these and see where we are. And for those some very bright shoes you have on. Because I took my answer from step 1, right? X can't equal 1 from step 1, and the answer that you get when you solve this, like those two answers together are your domain. What f of x can't equal is not part of your domain. Like you have to just solve that math problem. So you don't include negative 2 in your domain. You just include where g of x equals that number. Let's do another one and see if we can make some sense of it. Look how big this will be now. I haven't worked this one out yet, so let's see what happens. We still have, what time did we get out here today? Oh, it's 42, isn't it? I almost added more to these notes because I was going to do these yesterday, but then I did it and I thought it wouldn't be very much, but I think we're good to go. domain of f of g, what's the first thing we do? Write down problem. I guess I should wait for you to do that. So maybe we can kind of shorten this up now that we have the steps down. So step 1, what can't g of x equal? 0, because you can't have 0 in the bottom, right? So I can say x cannot equal 0. That's going to be part of my answer eventually. That's the easy part. The second part is you have to tell me what f of x can't equal, and then we set g of x equal to that number. That's step 2. That's the big hard step of this step today. So what can't f of x equal? F of x can't equal -3, or you can't have x is -3. So what we're going to do is we're going to set -2 over x equal to that value. I'm just going to kind of draw a line there so maybe you can see what that's coming from. So you take what the domain of f of x is, and you set g of x into that, because you're plugging g of x into f of x, so that's why that's going together. And then you're just going to solve it, which shouldn't be too terrible. Maybe. Again, can I just multiply by x on both sides? So I would get -2 equals -3x. And then I would divide by -3. And I would get, I guess I should say not equal to, x cannot equal 2/3. It's not so bad, right? It was just a lot of writing out. Questions on where I'm getting those from? Your final answer is just put those two together. So most of the time, you're going to have two different excluding values from your domain. And again, I'm totally fine with set notation. Oh, look at my awesome hair today.
You can't even tell.
It's awful in there. X such that x cannot equal 0 and x cannot equal 2/3. That's your domain. So it's just knowing those steps there. Tomorrow we're going to actually compute f of g in terms of x. And then maybe kind of work backwards. So we have, if it was g of f, you would have to switch that around. Right? Like whatever the second one is like the one that you exclude first, and then you do the other way. So if it was g of f and it asked for the domain, you would have to switch. Like this would become what does f of x not equal, and then set what g of x can equal f of x. But right, but I don't think they're gonna like that. But you're right. Yeah, but you're right. You'd have to switch the rules there for g and f. So this is 6-1, day 1. And you're just doing 12 through 27 multiples of 3. 12, 15, and 18 are doing the f of g, g of f, f of f, g of g. You're just computing with the numbers like you just did. And then 21, 24, and